to continue on this, the other topic which a lot of us have talked about and which is on top of our minds is cloud. And so the next session on migrating to the cloud will be by Abhishek Pathak, who's a customer engineer at Google Cloud. He's been with Google Cloud for over 10 years. And in that time, he's been helping many leading companies across various verticals to design and implement technical solutions for business critical applications, implemented both on-premise and on the cloud. And for most part of his career, Abhishek has spent time with enterprise platform technologies, and he specializes in multi-tenant, cloud-native, and hybrid architectures for core business applications. So please welcome on stage Mr. Abhishek Pathak from Google Cloud, who's going to talk about migrating to the cloud.
Hi. That was pretty big an introduction. Thank you so much for the generous introduction. What I'm going to talk today is about application migration in context of hybrid, right? And in next 20 odd minutes, I would try to encompass some of the top concerns that might be in your mind when you think of evaluating an architecture that involves clouds in some form or the other, right? Let's look at when we think of cloud native architectures, right? I mean, some of your classic applications, be it a core banking application or your ERP applications that you have been running for a long time may not look very different today than what they used to look, let's say 10 years ago or 15 years ago, right? But certain other applications within your suite have gone through a transformation. So while you might be a media house, you suddenly see you are streaming your videos to your consumers on mobile phones. If you are a bank, you are serving customers over mobile channels and internet channels. And those applications seem to have a slightly different architecture. And more so, they are adopting cloud for reasons that are listed over here, right? It could be productive developers or developer productivity. Come to think about it, if you do any custom development today, you realize the biggest cost is not the infrastructure on which that application runs. It's the resource, right? Those really talented engineers who build those applications for you, and their every minute counts. So if you are using them to do tasks that are not directly contributing towards the application that they are building, most likely you are losing money, right? Not only that, you are adding to their frustration, which further makes them unproductive. The second aspect is portability. Portability takes a completely different meaning in context of cloud, right? Earlier, you didn't like a vendor, you had the option of not buying from them going forward. But if you are so tight to the hip, your application is so tightly integrated by the cloud provider, you really don't have an option to move them elsewhere, right? And therefore, vendor lock-in becomes, the magnitude of lock-in becomes far more complicated in a cloud scenario, and that possibly could be one of the reasons why when you are looking as a consumer to introduce cloud in your architecture, there is some amount of hesitation, right? But a true cloud native application is designed grounds up with no ties to the platform underneath or the cloud vendor underneath, right? They are always very scalable. They are always available. These two aspects are, of course, given, right? And most importantly, running and maintaining these applications is extremely efficient. You conceive an idea, and from the time you conceive that idea to the time that you implement it, usually the windows are very short, right? Primarily because of the efficient and agile way in which you run these applications. And at the very end, we just heard the importance of security, right? Security in these applications are not afterthoughts. They are built into the application grounds up, and every feature considers security to be an important element of the design, right? So if I were to put this in a quadrant, right? If you want your infrastructure, if you want your entire enterprise to be cloud native, you want to be in this quadrant, right? Where you get all these benefits of cloud native architecture. At the same time, you enjoy the commercial benefit of being pay per use. That means if your application is making money, it is only then that you are spending money, right? But you are not starting a company today, right? You are already running it for many years, and it's like trying to do a kidney transplant and a heart transplant and probably a brain transplant while the person is still living, and all these 3 operations at the same time. Therefore, while most of us are here, right, and for good reason so, right? I mean, there was good reason because of which you chose to run RISC Unix platforms, right? There were good reasons why you went ahead and picked up every single element in your stack by very carefully evaluating them. But again, every evaluation has a context, and that context itself has changed over a period of time, and therefore today we call it rigid and expensive because the alternatives have become more flexible and inexpensive, right? So how do we do this move? How do we really take this path from moving to my current architecture, which is designed in a specific way, carrying the legacy of very good decisions but made in past, to these modern designs which are inherently scalable, are built on pay-per-use principles, are extremely secure, and keep our developers happy and productive? One way could be to think of it as a journey, right? But again, in the enterprise scenario, this journey is not trivial, right? Because you have your own data centers, and you have got cloud service providers who have unique capabilities that they can offer you. At the same time, your applications are itself very diverse. At one end of the spectrum, you have got these large ISV-based applications, be it your ERPs, be it your data warehouses, be it your specific industry applications that you might be running. And on the other hand, you have got these new mobile applications or new web-only properties that are cloud native, right? And you have to kind of operate both of them as homogeneously as possible in order to make sure that everything runs smooth. So how do you really move this journey, right? One approach could be rip and replace, right? This is probably the easiest thing. You go to the board and you say, hey, you know what? We are just going to wipe everything out and we are going to call it our company version 2.0, and I'm going to institute a project, give me hundreds of crores of rupees to reinvent this company. I'm pretty sure, you're at the very least, that particular proposal will get shot. At the max, the person who is carrying that message will get shot, right? So it's not going to work. For enterprises, it will certainly not get work, especially if you have been, running shop for a long time, right? And therefore, hybrid becomes the reality, whether you like it or not. The best approach would be that you continue to, evolve what you currently have, as well as start to integrate certain capabilities that are being offered to you by technology providers that are not operating in your data center, right? So simply put, hybrid, as I say in one line, is do what you want, where you want it, right? Whether you want to do it in your data center, you want to do it in service provider's data center, it all depends on what is best for that workload. And there are several ways to do that, right? One move could be to lift and improve. Here are some examples of companies, right, who have taken this approach and gained one aspect of those 6 or 7 benefits that I spoke about cloud native architectures, right? So one of that is, you basically take your workloads, instead of running them in your data centers, you start running them in your cloud service provider's data center. So you get pay-per-use benefits. Understand that cloud service providers do consider security as a very important tenet, and therefore, any decent cloud service provider would certainly have enough security footprint that you may have built for your data center, right? It's like you would expect bankers' lockers to be at least as secure as your own lockers that you might have in your own house, right? It's pretty much like that. So you start to leverage that security and the pay-per-use model and efficiency that the cloud service provider would provide you inherently, right? And that's one way to look at it. But there are challenges here, and this challenge, the biggest challenge there is migration. How do you really take your workload and move this to cloud, right? Without disrupting your large footprint that is already running. Well, that's where here is some data point around that. I'm pretty sure you live it every day, so I need not stress upon it too much. But here is a technology that can help you do that. Right? So we went ahead and folded this company into our Google Cloud portfolio called Velostrata, What it essentially does is something like this. You have got a, big VMware farm that you are running in your data center. You identify that, hey, these workloads, they are very transient in nature, or they could really take advantage of economies that are provided by your cloud service provider, and therefore I would like to migrate them to cloud, right? You could just simply install this component in your existing VMware infrastructure, right? And it would start to stream data to a VM, to a partner VM in cloud, right? Essentially, it's like creating a mirror of your workload from on-prem to cloud. And within matter of minutes, you don't have to copy the entire 20 terabytes of data that that particular VM has, right? VeloStrata provides you the intelligence to basically stream just enough what is needed to start working from cloud. And in the background, it will move all your workload to cloud natively, right? And this is the least possible disruption that you can expect. So if you have an existing workload that you want to move to cloud, VeloStrata would give you an opportunity to do so very easily. And please do come and visit us in our booth where we can show you a demo of that, right? So this is one approach. If you think that lift and improve is one of those strategies that would work for you, a simple technology like VeloStrata, which by the way costs nothing, right, could be a good way to start exploring cloud, right? Giving you the opportunity to make sure that you can easily move your workloads and test them out, and once you have the confidence that cloud is the best place for these workloads to reside, you could continue to run them there. The next approach, which I feel would resonate very well with some of our large enterprises who are sitting in this room, is to lift and improve, is to improve and move, right? And what is this improve and move, right? You take this approach of taking your existing application, all this footprint that you have in your data center, right? And you start to bring in the capabilities around making them portable, making them scalable, solving some of their availability related challenges, right? You do all of that on-prem, and once your application becomes cloud native, you start to move them to public cloud, right? Right? And how do you do that? Again, Google believes that this is one of those strategies that would really work well for customers who have large footprint in their existing data centers. And that's where we decided to bring in this architecture pattern and service called Cloud Service Platform. At heart of Cloud Service Platform is Kubernetes. I am pretty sure you are already aware of what Kubernetes is. Some of you might already be experimenting with it or are already running production workload on this. But Cloud Service Platform is an approach through which we would be able to provide you a consistent Kubernetes environment that would span towards your data center at one end and public cloud providers, irrespective of which public cloud service provider it is, on the other end. And you would be able to manage that entire environment through one single interface, right? As I said, at heart of it, it is Kubernetes and Kubernetes-based ecosystem, right? So you have got the core of Cloud Service Platform, which is Kubernetes and Istio. I'm pretty sure some of you may already be familiar with Istio as well, which is a service mesh technology. As more of our applications are becoming API-driven, you need a mechanism to allow these APIs to talk to, these components to talk to each other very effectively. And Istio helps you do that. This particular cloud service platform will provide you, a way to run a very effective environment of Kubernetes on-prem, as well as leverage the innovation that is happening in this space through use of marketplace. So you could have vendors and technology partners, as well as open source developers who would build technologies or build solutions on top of Kubernetes and publish them on marketplace, and you would just be able to import them and run them wherever they are. So tomorrow if someone creates a very good eKYC solution, for example, right, and makes it available on Kubernetes marketplace, all you have to do is simply import them and run it in wherever you want to run that, be it on-prem or on public cloud, right? So that's one another approach of lift and to improve and move your workloads towards public cloud. And all these all your digital footprint, this entire Kubernetes environment, you would be able to manage them through your cloud console in Google, right? Here is some information about how people are looking at it. You see big names like Apple, Marriott, some customers who are essentially saying that Kubernetes has that transformational capability, right, to change things and basically re-engineer your entire architecture. Let's move, so here is a summary of what CSP provides. I'm pretty sure by now that Kubernetes is a very popular platform. Some of it must be already known to you, but I would like to tell you that don't consider these technologies only as a way to deploy your application, or basically as something that is really cool and it is happening and you should just dabble with it. But the amount of lubrication that you would start to experience once you move your applications to containers is really something that you might have experienced when virtualization first happened, right? And all of us would agree today that there is no question that there are very rare scenarios in which you would want to run applications without virtualization, right? Similarly, in very soon, in very near future, you would consider that not running applications in container is just not an option, right? So you should certainly check these technologies out. All right, now there is one more approach that you can take, right? Apart from, this is more of a diagonal move towards this quadrant of cloud native architecture, which is basically to build and connect, right? So for example, how many of you, if just for a show of hand, how many of you are evaluating a computer vision based project in your environment, something that requires computer vision or probably speech analysis, speech to text, or workloads like that? Almost all of you, right? In some form or the other, you want to integrate them. You want to integrate computer vision. Now, if you look at the technical challenges of doing so, while there are technologies that companies like us have open source, be it TensorFlow or some of the other machine learning platforms that we have made available in open source, there is still a lot of heavy lifting when it comes to generating data as well as training those models and making it really production ready, right? So you could attempt that, or you could simply make an API call to a cloud service provider like Google and just get the responses in a JSON file that you could then integrate into your application, right? So everything essentially becomes an API call, and you are only composing these various API calls into your application to get the functionality that you need, right? And that could be one architecture. So your workload is essentially running on-prem, but it is extending its capabilities into public cloud, right, through use of these APIs. And that's where our API platform, Apigee, could be very helpful. As well as ability to connect your data center with our data centers would become also very useful. So one of the approach would be to extend your existing data center footprint and to our data centers, cloud data centers, through network. Google again has a very interesting take on it. Apart from being, managing our own large global network, we also have a lot of points of presence that gives you an immediate access to our networking infrastructure by simply peering with us. The three ways that you could do that, you could simply set up as simple as a VPN. So if your workload is small and you think that you just want a simple way to connect your network with our network, you could do that through a VPN. Or you could go and ask for a dedicated interconnect or a partner interconnect depending on the bandwidth requirements and availability requirements and SLAs that you might be interested in, right? Through this way, you literally have your data center boundaries being extended into service providers like Google, right? So essentially, in this space, as a technology service provider, we become your partners, right? We basically assist you to run your workload wherever they should run the best, right? So if you have some workload that you feel would run best in your premises, you should run it there, right? If you think that's something that could take advantage of cloud, you should run it there. If there are any engineering heavy lifting that needs to be done, that's the problem that we are interested in solving. And I have just shown you a few approaches into how we like to solve those, right? So that is it. This was my message to you. Hopefully this inspires you to start looking at your existing application landscape, your existing data center landscape, and start creating the bundles of those applications that you felt would fit very well in cloud, right? But you could never run them there because of migration-related challenges or integration-related challenges or network-related challenges. Today, you could start to relook at those applications once again. Thank you so much.